Question 22. Peter wants to find out how the arrangement of the bulbs affect the brightness of the bulb. So the change variable here is the arrangement of the bulb and the measured variable is the brightness of the bulb. So he set up 4 electrical circuits using identical batteries and bulbs in working condition. So which pair of circuits could he use for the experiment? So the only thing we should change here is the arrangement of the bulbs, which is in series versus in parallel. Everything else should be the same. So answer is P and R. The bulbs in circuit P are arranged in series. The bulbs in circuit R is arranged in parallel, which gives the brighter bulb. As for the number of batteries and the number of bulbs, it must remain the same. So answer is 2. Question 23. A, B, C are made of different materials. Which of the following shows the correct number of bulbs that will be lit when the materials are added at the various locations? So let's look at option 1. So steel and iron are conductors of electricity, but wood is an insulator of electricity, cannot conduct electricity. So with that, electricity can only flow through A and B, and as highlighted in the diagram above, this is how the electricity flow would be like, and there's a total of 5 bulbs that will light up. So answer is 1. Question 24. Diagram below shows 2 bumper cars in a non-sheltered outdoor amusement park. Part P is made of material that can be compressed when the car hit each other. So this is to prevent the damage of the cars. Below are some of the materials and their properties considered to make part P. So since it is not sheltered, it is susceptible to rain. So the material should be waterproof. As there's a lot of bumping involved, the material should also be flexible and does not break easily. So that is material A only. So answer for question 24 is 1. A only. Question 25. Diagram below shows the side view mirror of a magnet on a fridge door. Which forces is acting on a magnet to prevent the magnet from dropping? So that would be 2. Magnetic and frictional force. Gravitational force is acting on the magnet, however, it is to cause the magnet to fall. So it is acting downwards, it is in the direction of the magnet falling, but the question wants the force which is preventing the magnet from dropping. So that will just be the magnetic force and frictional force. Question 26. Peter kicked an empty can on the floor as shown in the diagram below. What are the possible effects of a force? So effects of a force would be able to change the speed of an object, stop the object from moving, change the shape, change the size, change the direction of the object, and also cause an stationary object to start moving. So A, B, C, D are all possible effects of forces. Answer is 4. The only thing to take note for this kind of question would be that mass cannot be changed. So for this kind of MCQ question, it's good to look out for the mass of the object being changed, so that will be the wrong option. But in this case, they don't mention anything about mass, and all of these are possible effects of a force. So answer is 4. Question 27. There are 2 bottles P and Q of the same size. Each bottle has a different groove pattern on its cap. Which cap will be easier to unscrew and why? So over here, we look at the different caps P and Q. The one with a better grip would be cap Q because it has more grooves to increase friction between the cap and the fingers, so it gives better grip. And with better grip, the person is able to turn the cap open more easily, so answer is 3. Question 28. The diagram below shows the cross-section of a toaster. Diagram A shows 2 springs at the original length when the bread is put in, and diagram B shows how the 2 springs are extended when the bread is lowered. After the bread is toasted, the spring will return to its original length, and they want to know how the toaster can be modified so that the bread will pop out higher. So replacing the spring with stiffer springs will allow the bread to pop out higher, because when we use stiffer spring, to reach that same level of extension as before, the spring will contain more elastic potential energy, which will then be converted to more kinetic energy and gravitational potential energy, allowing the bread to pop out higher. So A is correct. Use a piece of bread with lesser mass. This is not true because the extension of the spring is not affected by the mass of the bread. It is just a fixed length that is extended based on the machinery of the toaster. C, add another similar spring to each side of the toaster. So once again, this will allow more elastic potential energy to be converted to more kinetic energy and later on to more gravitational potential energy of the bread, so it can pop out higher. So A and C, answer is 3.